Okay, we're looking at page 71 and 72 of your handbook today, and we're going to investigate those exponents that we're kind of struggling with a little bit. And so I shared with you how the zero and negative exponents work last week, but we're going to kind of explore using patterns to see why they work the way they do. So if you first look at the first column, we have 2 to the third, and that's 2 times 2 times 2, which is equal to 8. So if we take that previous answer, which was 2 times 2 times 2, and we divide by a 2, well, this is going to be a 1. Anytime you have a 2 divided by 2, that's a 1. And so we really get that this is 2 to the second power. So using the law of exponents, that's going to be 2 to the power 3 minus 1, because that was the 2 to the 1 power. And so that is 2 to the second power. And so what happens is the exponent just decreased by 1. And so you can see we went from 2 to the third, now we're at 2 to the second power. So I'd like you to finish filling in this, so you should pause and try and fill in this chart and see what's going on. So let's see how you were doing. So 2 squared is 2 times 2, which is going to be equal to 4. And so if we take 2 to the second power, divide out by a 2, that's 2 times 2 divided by 2, which will be 2 to the first power. Again, we're looking at a 1 going on because we have a 2 divided by 2. And using exponent rules, that's 2 to the second minus 1, which is 2 to the 1. And again, our exponent is down by 1. Then we have 2 to the 1, that's 2. So if we take 2 to the 1 divided by 2, well, that's really just 1. Exponent rules, that's 2 to the 1 minus 1, which is 2 to the 0. And so you can see that our exponents keep decreasing by 1. And so when we get to 2 to the 0, you can see that that's going to be equal to 1. So again, our exponent decreased by 1. So then 2 to the 0, we know that that's a 1 already. And so if we take that 2 to the 0, divided by another 2, well, really that's just 1 divided by a 2. So we get half. Exponent rules, that's 2 to the 0 minus 1, which is 2 to the negative 1. So you can see 2 to the negative 1 is a half. So you can start thinking that when you have these negative exponents, it's kind of like dividing by 2. And you can see, again, our exponents decreased by 1. So then 2 to the negative 1, we already know is a half. So we're going to take a half and divide that by 2. Well, a half divided by 2 is the same thing as multiplying by 1/2. So to divide by 2 over 1 is the same as multiplying by a half. And so we end up with a fourth. But that means that 2 to the negative 1 minus 1, 2 to the negative 2, is equal to the 1/4. So again, that negative exponent, it looks like it's dividing by 2 2's, which is why we get 1/4. And it doesn't just look like it, that is really what's happening. Again, our exponents are down by 1. So for this last one, we know that 2 to the negative 2 is going to be 1/4. And so we're going to take a fourth and divide that by 2. But to divide that by 2, again, it's 1/4 times 1/2. So you can see that next 2 down there. And this 4 was the 2 2's. So we have 3 2's in the bottom to make 1/8. Exponent rules, that's 2 to the negative 2 minus 1. So we get 2 to the negative, not 8, 2 to the negative 3. So we can see that 2 to the negative 3 equals 1/8. And again, you keep seeing that our exponents are decreasing by 1. So we flip over to the next page. Again, you should pause and you should try this. We have a base of 5 to look at, and we also have a base of 10 to look at. So give you a little bit of time. So when we look at 5 to the x power, again, both of these are our exponential functions. But we want to see what's going on with those exponents as they get smaller and smaller and smaller. So we're going to start out by looking at 5 to the 4th, which is 5 times 5 times 5 times 5. which is going to be 625. So if you look at it, when we go from 5 to the 4th to 5 to the 3, it's like we divided by a 5. So if we take 5 times 5 times 5 times 5 to divide by a 5, that takes one of those away, which equals 125. 5 squared, that takes another 5 and divides by it. So we're like 5 times 5 times 5 divided by 5. We're left with just 25, which should be pretty familiar. 5 squared is 25. And so then 5 to the 1 is like, okay, well, let's take that and divide out another 5. So we get 5. And 5 to the 0, let's take that 5, divide out by another 5, and you can see that 1. 5 to the negative 1, that's 1 divided by a 5. And then we take 1 divided by a 5 divided by a 5 again. We get 1 over 25. So that negative 2 power means divide by 2 5s. The negative 1 power, we're dividing by a 5. And then 5 to the negative 3, we're taking that and dividing by 5 again. So really that's going to be now 3 5s in the bottom. So we're going to get 1 over 125. So hopefully that makes it a little bit clearer about what those exponents are doing. Let's see. If not, let's look at 10 to the 4th. So 10 to the 4th, that's 10 times 10 times 10 times 10, which will be equal to 10,000. So then 10 to the 3rd, it's dividing that 10,000 by a 10, which is going to equal 1,000. So then we take the 1,000, divide that by a 10, we get 100. So 10 squared is 100. 10 to the 1, that's taking that 100, divide by another 10, we get the 10 like you'd expect. Take the 10, divide by another 10, we get 1. So 0 powers make us get 1. 10 to the negative 1, we'll take that 1, divide by a 10, so we have 1/10. 10 to the negative 2, we divide by 10 again, so that's 1 over 10 times 10, so that's 1 over 100. And 10 to the negative 3, we divide by 10 again, and so we get 1 over 1,000. So I'm hoping that you made some sort of observation over here, and I've also kind of made a few statements, but let's take a look at these 3 little questions. So it says compare the 2 powers. So we have 5 to the 1, 5 to the negative 1. So both 5 to the 1 and 5 to the negative 1 have a 1 as a power, but when you have the negative, we can see that 5 to the 1 gets us the 5, but 5 to the negative 1 got us 1 over the 5. When we look at 5 squared, we know that that was 25, and then 5 to the negative 2 is 1 over that 25. And the 0 power, I pointed out 5 to the 0 power was 1, and 10 to the 0 power also 1. So what I'm hoping that you can kind of see, and maybe it's a little clearer now, is that when you have any number a where a is not equal to 0, and you take it to an exponent of 0, you'll always get 1. And you can think about it because you're dividing by the same number of bases. Like you saw up above, we had like 5 divided by 5, 10 divided by 10. And then the negative exponents, anytime you have a negative exponent, really you're just dividing out. So it becomes 1 over a to however many number of them that you have. So these are a few exponent rules that you're going to see on and off all the time when we saw them when we were graphing our exponential functions, but we're going to play with those a little bit more.